In the middle of the northwestern Saudi Arabian desert, a perfectly straight cut is beginning to appear. Not a road, not a pipeline, but the first visible trace of the most ambitious construction project humanity has ever attempted. The line. A trench 200 meters wide stretches from the Hejaz Mountains all the way to the Gulf of Aqaba, slicing through sand, rock, and coastal plains. Here, tens of thousands of machines operate day and night. Millions of cubic meters of earth are displaced, and thousands of concrete piles are drilled deep into the ground. A 170-kilometer-long linear city, 200 meters wide and 500 meters tall, a project in which Saudi Arabia is staking not only its wealth, but its national credibility and its post-oil future. The question is no longer whether the idea is bold. The question is how it is being built and whether it can truly become reality. The line is the centerpiece of NEOM, a completely new development region in northwestern Saudi Arabia. The project was initiated by Crown Prince Mohammed bin Salman as a cornerstone of Vision 2030, a national plan aimed at restructuring the country's economy, reducing its dependence on oil, and shifting towards services, technology, tourism, and real estate. Conceptually, the line is a massive linear city stretching 170 kilometers across the desert. It is described as having no cars and no traditional streets, with all essential services located within a 5-minute walk. Long-distance transportation relies on a high-speed rail system, while energy is supplied by wind and solar power, and water comes from desalination plants. The project is estimated to require a total investment of around $500 billion, making the line one of the most expensive urban ambitions ever proposed. If completed according to its original vision, the line could accommodate up to 9 million residents. But in the harsh desert environment, the distance between an idea and reality is vast. The greatest challenge facing the line lies not in its vision, but in turning that vision into a system capable of operating continuously, reliably, and sustainably. When the line was first announced in 2021, many people believed it was far too radical an idea to ever become reality. For years, the project was widely viewed as a large-scale publicity campaign, defined by images of mirrored glass walls stretching to the horizon and promises of a zero-carbon city that felt closer to science fiction than real urban planning. But by the end of 2022, that perception began to change, as drone and satellite images revealed that construction was actively underway. In the desert, service roads were carved out, heavy machinery operated continuously, and a massive trench gradually took shape, extending for kilometers. At this stage, the project officially enters an unprecedented phase of large-scale groundworks. Fleets of bulldozers, excavators, and heavy-duty trucks are deployed simultaneously in linear formations, operating around the clock. Earth and rock are not simply excavated and removed, but carefully sorted, leveled, and redistributed to establish stable elevations along the entire route. Temporary service roads take shape alongside the trench, becoming the vital arteries for transporting equipment, materials, and manpower. This is the moment when an empty desert begins to transform into a highly organized construction site, operating with the pace and discipline of an industrial-scale infrastructure project. However, trench excavation is only the beginning. The real challenge still lies ahead: how to build a structure hundreds of meters tall on the harsh and unforgiving geology of the desert. The terrain along the line varies continuously, from hard mountain rock and soft desert sand to coastal plains with saline groundwater. Over a length of 170 kilometers, the project cannot rely on fragmented foundation solutions and instead requires a foundation system that is uniform and highly stable. The solution chosen is a pile raft foundation, in which the building loads are transferred down to the bedrock through deep concrete piles, topped by a thick concrete slab that distributes the loads above. This technology is not new, but it has never been implemented at a scale like that of the line. With 16,000 piles, extreme depths, and enormous volumes of concrete, the underground structure becomes the project's greatest technical challenge. But weak soil is not the only obstacle. Building near the coast also introduces another enemy: saline groundwater. Saline groundwater poses a long-term threat to concrete and steel reinforcement, as it can cause corrosion and gradually weaken structural integrity over time. To control this problem, a large-scale dewatering system has been implemented. Around 500 wells were drilled along the construction corridor, each equipped with high-capacity pumps to continuously extract groundwater, which is then routed to settling ponds for treatment before being discharged into the Red Sea through an extended pipeline system. The pumping capacity reaches tens of thousands of cubic meters per hour, making this one of the largest dewatering systems ever applied to a civil construction project. Although the excavation corridor stretches for dozens of kilometers, the section being developed into a completed structure in the current stage measures only approximately 2.4 kilometers. This is Phase 1, accounting for less than 1.5% of the total length of the line as originally promoted. Phase 1 is divided into 3 modules, each approximately 800 meters long and rising up to 500 meters high. The objective of this phase is not to complete the entire city, but to create landmark structures capable of demonstrating the project's feasibility and attracting global investment. This strategy is commonly described as the development of anchor assets, key elements designed to catalyze growth across the surrounding area. This segment also marks the first section of the internal rail line, directly connecting to the hidden marina and the Neom Stadium, one of the venues selected to host the FIFA World Cup 2034. Among the modules, Module 45 is currently progressing well, with concrete pouring having officially begun on site. Module 46 is the most heavily funded module, as it is where the hidden marina will cut through the entire linear structure. At the same time, this module is also the location of the Neom Stadium, a major sports facility positioned approximately 350 meters above ground level, embedded within the structure of the line itself. Beyond the question of whether the line can be built from a technical standpoint, the project faces a larger issue: whether it can operate as a real city under desert conditions. The first challenge is temperature and urban microclimate. The line has confirmed it will not use air conditioning for outdoor spaces, meaning all public activities must directly adapt to the natural climate. In a structure of extremely high density, with hundreds of kilometers of concrete, steel, and glass, the risk of an urban heat island effect is unavoidable. To reduce heat absorption, the project places great expectations on the reflective glass facade covering the entire exterior of the structure. At the same time, solar and wind power systems operate in parallel, providing continuous clean energy for the entire city. However, maintaining the effectiveness of the reflective facade in an environment of sand, strong winds, and extreme temperature fluctuations remains an unprecedented challenge. Alongside the climate issue is the transportation challenge of a linear city. With only 2 primary directions of movement along its longitudinal axis, the line is designed to eliminate private cars and rely on public transport. Yet this very characteristic also makes the system more vulnerable to disruption. A single interruption on the main axis could lead to widespread congestion. By 2030, the line will no longer be just drawings or a construction site in the desert. Reflective architectural volumes rise from the sand, enclosing a green urban core within. The hidden marina welcomes super yachts docking between 2 colossal glass walls, while interior spaces covered in greenery create distinct layers of microclimate. Further along, symbols once considered far-fetched, the elevated stadium, the internal boulevard, the renewable energy infrastructure, begin to take clear form. The year 2030 is not merely a milestone, but a decisive moment. The line proves its feasibility, or becomes the greatest unfinished ambition of the century. To sustain life in the harsh desert, the line cannot exist without a reliable water supply. Behind it lies a vast network of pipelines carrying seawater across the desert, turning what once seemed impossible into essential infrastructure. Saudi Arabia has more than 37 million people, and almost the entire population follows Islam. What is particularly notable is that most of the population is densely concentrated along the Red Sea coast and the Persian Gulf. Remains an almost uninhabited desert. Saudi Arabia possesses what the world desires most: oil. But nature never gives everything.
The city will use carbon neutrals for water storage can be seen.
The country still has to spend billions of dollars to produce every single drop of fresh water. Average annual rainfall is below 100 millimeters, while summer temperatures regularly exceed 45 degrees Celsius. To survive under these conditions, Saudi Arabia built a nationwide water pipeline system. The network uses high-strength carbon steel pipes, similar to those used in the oil and gas industry. Construction costs average around $3 million per kilometer of pipeline, not including booster pumping stations and advanced desalination plants, each of which can cost tens of millions of dollars. But where does this pipeline get its water from? They turn to a nearly inexhaustible source, seawater. However, seawater contains about 3.5% salt, too salty to drink or use for irrigation. That's why desalination technology was developed, giving Saudi Arabia a nearly unlimited supply of usable water. The pipeline carries water from giant desalination plants located next to the Red Sea. Each day, such a plant can convert 7 million liters of seawater into drinking water, consuming a huge amount of energy. The installation process begins at large staging yards located along the pipeline route. Here, fully manufactured steel pipe sections are grouped by diameter, length, and installation sequence. Engineering teams carry out final visual inspections, checking pipe straightness, coating condition, and identification markings. Proper organization at the staging area is essential to maintain a continuous workflow, minimize delays, and reduce errors when operating in harsh desert conditions. Before trenching begins, the construction site must be cleared and leveled to allow heavy machinery to operate smoothly. Temporary access roads are opened parallel to the pipeline to accommodate trucks, excavators, welders, and material transport vehicles. In the desert, site preparation also includes dust control and sand stabilization measures to ensure visibility and worker safety. This is a fundamental step that ensures the smooth operation of the entire construction process throughout the project. Once the route is finalized, large tracked excavators begin digging the trench along the marked alignment. The trench is excavated to precise width and depth, allowing enough space for pipe placement and backfilling. Excavated soil is sorted on site. Suitable material is retained for backfill, while unsuitable soil is removed. Maintaining consistent trench depth and alignment is essential to prevent pipe deformation or misalignment after installation. In addition, along certain pipeline sections that cross steep and rugged mountain terrain, explosives are used to carve trenches directly into solid rock, place controlled charges, and detonate them in sequence to fracture the bedrock along the planned alignment. The resulting blasted trench creates enough depth and width to seat the pipeline securely, even in areas where mechanical excavation is impossible. This method allows construction to continue through extreme landscapes while keeping the pipeline buried, protected, and structurally stable. After excavation, the pipe is not placed directly onto the trench floor. A layer of selected material, typically fine sand or screen soil, is spread evenly along the bottom to create a bedding layer. This layer distributes loads uniformly and reduces stress concentrations on the pipe. The bedding is leveled and lightly compacted to achieve the required elevation. In desert terrain with loose, dry soils, this step is crucial for long-term stability. To construct large-diameter pipeline routes, a construction corridor approximately 40 meters wide is prepared in advance, allowing the entire installation process to proceed continuously at an average pace of about 1.5 kilometers per day. Pipe sections measuring around 18 meters in length are selected to reduce the number of field welds, while also imposing very high demands on lifting, transportation, and precise alignment throughout construction. At the welding site, a hydraulic internal lineup clamp is positioned inside the pipe joint and expanded with 360-degree gripping shoes to hold the two pipe sections perfectly concentric and actually aligned before and during the route pass. An automated welding operation, supported by a workforce of roughly 80 personnel and dozens of specialized machines, is deployed and can complete up to 150 welds per day on 42-inch diameter pipes. Once welding is finished, every joint undergoes automated ultrasonic inspection to ensure there are no internal defects. The field joint coating crew then performs abrasive blasting to clean the surface and applies a multi-component liquid epoxy coating, forming a durable, fully sealed protective layer before the pipes are lowered into the trench and backfilled. The assembled pipes are lowered into the trench using side crane tractors, specialized tracked vehicles designed for constructing large-diameter pipelines. Multiple side booms operate in sequence along the pipeline, each lifting a section of the pipe string using padded slings and steel cables to protect the coating. The pipe string is raised evenly and held suspended above the ground as the machines move slowly along the trench. Precise coordination between operators is essential to prevent twisting, bending, or contact with trench walls. When aligned correctly, the pipe is lowered gradually, centimeter by centimeter, until it rests at the center of the trench on the prepared bedding. Throughout this process, surveyors continuously monitor pipe elevation, straightness, and natural curvature to ensure no residual stress is introduced. This method allows fast, controlled, and highly accurate placement, making it ideal for long, straight pipeline routes across flat desert terrain. After the pipe is positioned, the trench is backfilled in multiple layers. The initial layer consists of fine material to protect the pipe coating, followed by the previously excavated soil. Each layer is mechanically compacted to achieve the required density, minimizing future settlement. In desert conditions where soil structure can be affected by wind and temperature extremes, proper compaction is critical to pipeline longevity. The process begins by drawing seawater directly from the open ocean and channeling it inland, establishing a steady and uninterrupted supply of raw water for the desalination facility. Large intake lines are first positioned offshore, where installation crews carefully align each section before lowering it into place with heavy lift cranes operating from barges or coastal platforms. As the pipeline extends toward the shoreline, individual segments are connected sequentially, forming a continuous conduit designed to operate under constant hydraulic load. Precision alignment is critical at this stage, as even minor deviations can affect long-term performance and flow efficiency. Once assembly is complete, the intake line is reinforced with structural support frames and securely anchored to the seabed. And it is precisely those seawater pipelines stretching across the desert that laid the groundwork for an even greater ambition: the line. From water infrastructure and energy systems to piles driven dozens of meters deep, this project is not just a city, but a test of the limits of engineering and political will. Will it become a symbol of the post-oil future, or the most expensive lesson of the century? The answer is still being written in the Saudi desert. Like and subscribe to Mandarin Tech so you don't miss the projects that are redefining the limits of human potential. Because what seems impossible today could become reality tomorrow.